Welcome to our Azure Incident Retrospective. I'm David Steele.
I'm Sami Kuba. We work in the Azure Communications team.
In addition to providing a written post-incident review after major outages, we also now host these retrospective conversations.
You're about to watch a recording of a live stream where we invited impacted customers through Azure Service Health to join our panel of experts in a live Q&A.
We had a conversation about reliability as a shared responsibility. So this includes our learnings at Microsoft, as well as guidance for customers and partners to be more resilient.
We hope you enjoy the conversation that follows. And super, today's focus area is going to be an issue with our network and connectivity issues for traffic passing through our Toronto edge site. This impacted customer for about 2 to 3 hours on the 3rd of March. And it could have been any region that was impacted, but it was mostly predominantly in Canada, but anything going from that edge site going outwards.
That's right. So to talk us through the impact and our learnings today, I'd like to introduce the engineering leaders joining us on the panel live in person here from Redmond, Washington. We have Yushun Wang, our Principal Program Manager, and Somesh Chaturmata, who's our Partner Software Engineering Manager. Both of them are from our Azure Physical Networking team. Thank you both for joining us today. I'm excited to understand more about this incident.
Super, Thank you. Yushun, can I please start with you? How does traffic get onto our network in the first place, and what role does an edge or a POP site play in something like this?
Yes. So I think definitely, so for the traffic entering the Microsoft network, and typically this is via what we call the edge location or the edge POP, point of presence is what the industry usually call. So we do prepare a slide to talk about kind of the architecture, if you can show the slide right now. So you can see in the middle of the screen, that's actually the edge POP or the edge location, and we call it out. This is in Toronto, right? So on the right-hand side, you can see that this is usually where the major internet service provider, carriers, et cetera, and also major cloud providers such as Microsoft. So that is the location where the network interconnects together. So on the right-hand side, you can imagine this is Toronto. So we probably have Bell Canada, we have Shaw Communication or the Rogers Communication coming in. And at the bottom of the box, you see the ExpressRoute devices there. So this is the second categories of traffic from the customer enter into the Microsoft network. So that's where ExpressRoute circuits connect to the Microsoft ExpressRoute devices, enter into the Microsoft network. Now, let's talk a little bit on the left-hand side. What's behind the edge site locations and things like that, right? So obviously there is the Azure data center location where the customer traffic try to access the Azure services provided inside the data centers. In this case, because it's Toronto, so it's actually connected directly to our Canada East and Canada Central location via the metro fiber, the long haul fiber, etc. Now, another important thing to call out is also that all the Microsoft services all run on this same global network. So we're talking about services such as M365, Exchange, SharePoint, Teams, or Bing Search, etc. So that is kind of the role of the edge site plays in this particular picture, right? And you can also see that just kind of a very typical architecture that we have, that at any given point of our network, we always have at least 2 devices, links, etc. And sometimes 4 or more, depending on the demand, the diversity requirement, and also the SOA requirement that we have. So let me pause here a little bit. So this kind of give you an overview of what the edge site is and what the traffic looks like.
Yeah, that's great. I like you drawing attention to the different kind of levels of redundancy that we have in there. One of the acronyms on that slide that people might not be familiar with, the RNGs, those are our regional network gateways.
Correct.
Would you like to touch on how that works?
Sure. So if we bring back that slide. So RNG is what we call basically the network facility at the edge of the data center. So any traffic going in and out of the Azure data center region on Canada Central, US East, Japan West, etc., it all enter via the RNG facility before they go into the data center. So that's kind of our network facility, kind of similar to the edge site, but for the data center.
Got it. Okay, that's helpful to understand. So no matter how things are getting onto the WAN here, they're coming through one of these edge sites.
Correct.
Okay.
That's
so
correct.
We mentioned that this incident was to do with one particular edge site in Toronto, but what did customer impact feel like? What was the pain? What worked? What didn't work? And how do we kind of start to see these customer symptoms?
Sure. So the actual core issue was that, as we described in the PIR, a router can back up and it is dropping a lot of packets. So from the customer perspective, right, usually what they saw is that the various degree of impact, right? On the lighter side, they may see like longer application delays, somehow things take a long time to respond, or the throughput degraded, so downloading a file, accessing a file actually takes a long time, etc. But on the more severe side, the connection would just time out, or even though on the back end, it may keep retrying, but customer may see like connectivity as in on the service not available or service disconnected. So these are on the more severe side of the impact. And unfortunately, I think in this case, customer did see a more severe impact, such as application, such as Exchange, email just kind of become unavailable, Teams call become extremely choppy, etc. Right? So even just getting disconnected, booted out of the call. So it is a very bad impact.
So, if I'm to understand this, from reading the PIR, on the 27th of February, we made a change. And everything was kind of fine, or there didn't seem to be any issues. But then on the 3rd of March, not only did we see a device fail, I mean, devices fail all the time, and we have an inordinate amount of redundancy, but we saw our redundancy fail as well because of the same issue that was a change back in February. Up until then, had we seen these kinds of changes or these failures? Were there any red flags that were popping up? Or
Sumesh, you want to take?
Yeah. So as you mentioned, right, we made a change on 27th of Feb, and that was change done in the DC network. The change particularly was to change the routing database, and that increased the scale of our routing database. Is the number of routes that the router holds in that memory increased significantly that day. And since then, some of our devices which has the older line cards started to see the failure. The failure of the line card was not the problem. In case of Toronto, it happened on redundant device at the same time, and that's what impacted the issue, caused the issue in the Toronto edge site. And if I look back, we did see the signatures starting from 27th of Feb that our line card memory was increasing. And as we mentioned in the PIR, we monitored the memory on the line card on the router, but we did not monitor the memory on the line card. So if we had monitored the memory on the line card, we would have seen it soon as the change was done on the 27th, that the line card memory is already full at that point of time. Unfortunately, in the Toronto edge sites, we had both devices failed at the same time, and that caused the impact on the Toronto side. And we look back, the 27th of Feb change, as we were trying to replace the line card. If we were on process to replace all the line cards on our hardware devices with the memory that we had. If that change would have not been done, then we would have been fine with this line card memory at that point of time. So yes, the change was on 27th. Toronto had the multiple failure at the same time. So that's what the
That's good to understand and for you to explain. And you've teed us up quite nicely here when we start talking about the incident itself. So I want to pivot us over to talk about detection, investigation, and ultimately how we mitigated it. But on the detection point, Sumesh, you started by talking about this was a bit of a monitoring granularity gap, right?
Yes.
We were monitoring memory, but we weren't monitoring memory on the line card. So how did we detect this issue and what did we do about it?
Correct. So if you look at the timeline graphic, the issue started at around 1622 UTC when the second redundant router had the line card failure. And our team got a notification from our synthetic monitoring within the 10 minutes of the outage that we have an impact from the users in Toronto. But our synthetic monitoring identified a particular provider which had the network congestion in our Toronto edge POP or edge site. Our automation start to bring in the second device, which is the redundant device, which was down that time, to bring it online. And as you can see from the timeline graph, that the recovery actually started soon, within the 10 minutes after the outage occurred. But the complete recovery took 2 hours and 15 minutes. But if you look at this graph, first we had the DRI engaged, try to handle the particular provider for which we had the congestion. The DRI followed the safe procedure guideline and followed the steps to make sure that we can remove the congestion from a particular provider. That also reduced the impact to all customers, to some customers. And then after that, we had DRI take out the bad router to overload the router, and that reduced the impact further. And then finally, when we identified that, hey, we have some traffic that is not moving away from this router and we have to shut down the line card, which is the bad, then we had to take a manual action from DRI. And that time we shut down the line card, and that took us about 2 hours and 15 minutes to complete the entire recovery. But during the entire incident, we were recovering as we were taking the steps from the mitigation.
Thank you for explaining the kind of the timeline there. It's helpful to understand. And I'll just translate. You have to put a dollar in the acronym jar. DRI is our directly responsible individual, or the on-call engineer from the networking team at that time. Okay, thank you so much.
So one of the things I was fascinated around is we could have, or why don't we, or when do we remove the edge site or remove the POP? If we know that this edge site is giving us issues, we have the capacity and redundancy within our network. Why wouldn't we just remove the POP or the edge site?
So I can give it a try. So can we flash back to the architecture slide that we have on the Toronto edge location? I think definitely that is a valid point, and that is a valid mitigation if we want to go that path, right? But if you look back at this particular diagram, as we mentioned earlier, there are two categories of traffic. There's the internet traffic and there's the express route traffic. Definitely for the internet traffic, we can fill out completely from the location. What would happen is that the traffic would just come via nearby location, HPOP, other HPOP in nearby locations. Customer may see a little bit longer latency from the application responsiveness points of view, but by and large, the traffic should get through because we did capacity plan this week considering the failover. Now, the problem is that we do have the express route circuits and devices in that location. And these are not just for accessing M365 services. A lot of the customers use that for their internal kind of workload to workload communication. That is critical. And a single express route circuit is only present in a single edge location. So if the edge location were to be completely removed offline, the customer express route connectivity would have been completely broken. And I think we keep emphasizing the importance of having a redundant setup for the customer express route circuit. In this case, customer will need to have kind of a second or even a third express route circuit in a nearby location or in a different location that can provide this redundancy. Now, because we have express route traffic presence in this particular edge location, that makes us, it is one of the factors that we cannot simply just say, okay, let's remove this edge location from our network map to some extent. So that contributed to a little bit longer latency, or sort of delay in mitigating the incident. So that's the primary factor that we have there.
Yeah, that's great to understand. I think a lot of our customers would say, wait, if you knew there was a problem in the POP, why wouldn't you just take it away? And that would have been fine for some scenarios, but not fine for other ones. Okay, so if we pivot over to talk about some of our learnings and repairs coming out of this, one of the items that was listed in the preliminary post-incident review was about scanning or analyzing for this memory issue. We flagged that as completed, but we didn't really give an update on that analysis. What did we find? And was this was broader than just Toronto, right?
So much.
Yeah. So we scanned the entire fleet of our network, and we found all the routers which were running older line card had the same memory issues, because this routing change which was done in the DC network was propagating the route globally to our entire fleet. And after that, we found a setting that we can turn it on the devices to reduce the memory on the line card. We are also now expediting our replacement of our line card on every devices that we have to upgrade the line card with more memory.
Right, because even though you say this was global in nature, you're saying it just impacted these kind of older line cards. So you said it was across the entire fleet, but really it was quite a specialty thing, right?
Correct.
Okay, good to understand.
So, so, I mean, in the repair item, we set down, hey, we've done the scan, we've completed it for Toronto. Are we scanning other sites? Do we need to make changes in other sites? Are other sites at risk?
Yeah, we have done that work, and we have completed and fixed all the sites, including Toronto.
Okay, and we did this by not changing all the line cards, but by changing the configuration.
Configuration setting right now, and then we are now expediting our replacement of our line card as well.
Super.
Great, which was work that we were going to be just accelerating that.
That's
okay. The other repair item I wanted to touch on, and we mentioned it earlier, was about monitoring for memory usage.
Yes.
And how we weren't doing that on the line card itself. Is that work in progress, or are we already in a better space in terms of monitoring for line card specific memory issues?
Yeah, this one was the interesting find for us. We generally thought that the memory on the router will get full before the memory on the line card will get full, because the line card holds only this small portion of the routing information database. But these older line cards actually ran out of the memory faster because of the increase in the routing database. So we have now alert for monitoring the memory on the line card, and that alert gets fired automatically now if the line card memory gets full.
It's already in place. That's cool. It's refreshing to hear us say, hey, this is how we thought it worked, and we were wrong. We like to say outages teach us something new and exciting about how the cloud works. So we definitely learned something there.
Okay.
So from a customer perspective, is there anything customers can do? I understand the customers using ExpressRoute are in a great place and using active-active is a good one. But is there anything other customers could have done in a situation like this? Or is it a case of having applications to have retry? Or what could customers do?
I think definitely have the redundancy setup, such as for the ExpressRoute customer having backup ExpressRoute circuit. We recommend running active-active, but based on customer situation and things like that, right? And the second thing that definitely some of the major customers, they do have, even from the internet service provider point of view, they also have their kind of a backup internet service provider. Usually it's kind of active standby. So that's also an important measure that sort of the corporate customer can take and should take. And in this case, though, I think one thing we often hear from the customer that they're alerting kind of get the alarm earlier than our alerting sound. So unfortunately, sometimes that is the case, and that is because customer knows what they need, and they kind of have a more granular monitoring for their workload. That's not an excuse to say, okay, from our infrastructure point of view, we should not detect faster. But when customer sees that, I think it is important for the customer to also make a kind of a quick decision based on the telemetry that they have seen and to decide on the failover. And in this case, this is an internet service provider failover. It can be more sort of impactful even for the customer side, but that is a great redundancy setup that they could have. Now, flip to the application side, on the other hand, right? So what we said is that this is not a complete blackout, even though for some customer it looks like that. So some traffic did get through. So having a robust retry logic always helps. Right. So as in and in some cases, the application setup that's slightly more resilient for those kind of situations did get through. But yes, the response is actually much longer. And on the other, this is not to say, okay, customer does this and we don't need to do anything. No, this is just to say how you can protect yourself and make your workload, make your application smoother in the situations like this. And on our side, definitely we need to take all the necessary steps to prevent this kind of issue from happening again and to detect, mitigate sooner rather than having customer go through the pain. Yeah,
sure. Yeah, that sounds great. And we've run through, a bunch of different learnings from the monitoring perspective, as well as kind of phasing out these line cards eventually. So lots of goodness to come. I saved my last question for my co-host, Sammy. Sammy runs our incident communications team. And so, just as our service team had some learnings here, I wanted to ask Sammy, how did communications go? Were we able to keep all of the impacted customers up to date with what was going on?
To a degree. I think in the beginning, one of the things that Yushan touched on is customers will know when the electricity goes out before the electricity company tells them. And of course, their monitoring is far more granular. So as this issue came in, it started at 16:22 UTC, and other teams weren't engaged until about an hour later. And it was only about an hour after that until the communications team were engaged and we started sending out communications. We tried to be very transparent with what we know as the information came in at the time, but I think there would be a 2-hour period, up to 2 hours, where customers didn't have the information that they need and they were trying to look for things. We did communicate to the status page because we couldn't assess which customers have traffic going in and out of that edge zone. But then later on, we targeted customers in Canada because most customer impact would have predominantly been through Canada. Again, I talk about the way we try and reduce the speed. So when the lights go off because of a power outage, that customers kind of know before the power company tells them, we invest in Brain. Brain is our automated communication system. But because resources were still healthy and it was just traffic traversing, it's a non-trivial problem to solve. We are making investments, and we've been speaking about the investments we've been making with auto declaration and so on. That's a building block for Brain, but we still have a while to go before we can auto-communicate incidents like these in the future.
Thank you for watching this Azure Incident Retrospective.
At the scale of which our cloud operates at, incidents are inevitable.
Just as Microsoft is always learning and improving, we hope our customers and partners can learn from these too, and provide a lot of reliability guidance through the Azure well-architected framework.
To ensure that you get posted incident reviews after an outage and invites to join these live stream Q&A sessions, please ensure that you have Azure Service Health Alerts set up.
We really focused on being as transparent as possible and showing up and being accountable after these major incidents.
Whether it's an outage, a security, or a privacy event, Microsoft is investing heavily in these events to ensure that we earn, maintain, and at times rebuild your trust. Thanks for joining us.